Hello everyone, myself Bharadwaj. In this video, I will explain cyclic and acyclic communication in a macrocycle. I will take one example. Let's say I have a DCS system and I'm considering one junction box. That means one segment. I have a flow transmitter and its reading is 120 meter cube per hour, and a pressure transmitter, 8 bar pressure is there, and a temperature transmitter 85 degrees centigrade, and a control valve. Right now its position is 65% open. Now I will take one macrocycle. I am assuming 500 milliseconds macrocycle. So this macrocycle is divided into two parts. One is cyclic communication to exchange the data between field instruments and the control system. Which data? Process parameters like process variables, I mean the measured process parameters, right? And another part is acyclic communication for the calibration purpose or for the configuration of the device. Let's say this 500 milliseconds macrocycle is divided into two parts, right? The first part is cyclic communication, and it is having 350 milliseconds of time in this macrocycle. This is used for process control. And 150 milliseconds is for acyclic communication. This is for diagnostic purpose or configuration of the device. In this case, the approximate ratio is 70% and 30%. 70% for cyclic communication, 30% for acyclic communication. Remember, these are not fixed settings. These will be decided by the link add to scheduler, depends on so many parameters. Okay, it is not fixed. This is for example case. I'm considering this for easy explanation purpose. There are so many other variables also. I'm just considering the main parameters so that I can explain you in a simple, easily understandable way. So there are other things I'm not showing you here. Okay, I'm just showing you the main parts. Cyclic communication, what happens? It uses publisher subscriber model. That means the field instruments will publish its data to the communication bus and it will reach the DCS system. The field instrument acts as a publisher, the DCS acts as a subscriber. Because the DCS is the receiver, that is why it is called as subscriber. And the field instruments publishing the data, that is why it is called as publisher, right? Now, let us say the live list is also updated as per the sequence here. The first one is flow, next one pressure, temperature, and valve. So the flow transmitter publishes its data to the communication bus, right? And I am assuming 50 milliseconds time period for each device. In this case, I'm just assuming some run number, okay, for easy understanding purpose. Clear? Now, in the 350 milliseconds time period, 0 to 50 milliseconds will be used by the flow transmitter. It is publishing its reading to the communication bus. See, okay, 120 meter cube per hour. And after 0 to 50 milliseconds, again, the pressure transmitter publishes its data. So the next one is pressure transmitter is publishing its data to the communication bus. See, 0 to 50 milliseconds is flow transmitter, 50 to 100 milliseconds is pressure transmitter. The next one is temperature, 100 to 150 milliseconds. And the next one is control valve, 150 to 200 milliseconds. So how much time is completed? 0 to 200 milliseconds is completed. What is the total time of cyclic communication in one macrocycle? It is 350 milliseconds. So we have some time left, right? So this is the spare time in the cyclic communication. After completion of the 350 millisecond cyclic communication, then only it will go for the acyclic communication. If there is any spare time, there will be no activity will be performed by the link add to scheduler. So the 0 to 350 milliseconds time period is called as cyclic communication and used for process control, or it is a real-time data exchange between field instruments and the DCS. And this one is having highest priority on the communication bus. If you see here, this is called as scheduled and deterministic communication. The control system knows that at 0 to 50 milliseconds, it will receive flow transmitted data, and 50 to 100 milliseconds time period, it will receive the pressure transmitted data, 100 to 150 milliseconds temperature transmitter, 150 to 200 milliseconds control valves data. It is a scheduled timing, and the control system 100% knows that in this time slot, I will receive the data. That is why the foundation field bus is one of the important communication bus, because it is having deterministic communication. It works on the scheduled time basis, right? And after completing the 350 milliseconds time period, it will assign the remaining time for the acyclic communication, right? So after 350 milliseconds, let's say there is some request reading FT range. Okay, it may perform that. If we have any other request, then also it will assign that other request like temperature transmitter diagnostics. And if there are no requests, then it is a spare time. Let's suppose in acyclic communication, there is no time available. There is no time slot is available. Then what happens? Then, as this is the lowest priority, the link add to scheduler, it will instruct that please wait. I don't have any time slot available. In the next macro cycle, if there is a time slot available, then it will assign that time slot. In the acyclic communication only, remember that. If there is any time slot available in cyclic communication, it will not assign. Only the acyclic communication, if there is a time slot, it will assign. Otherwise, it has to wait. As it is a deterministic communication, the cyclic communication must happen in a predefined or scheduled timings. It cannot change based on the on-demand messages. That is why the cyclic communication consumes more time on the macro cycle. 60 to 80% it will take, and remaining 10%, 20%, it will be assigned to the acyclic communication. Let's say the acyclic communication still have some job, still needs more time slots to complete the job. Then in, let's say this is first macro cycle. In first macro cycle, it will assign some time slots. It needs again some more time slots. Then the link add to scheduler will assign the job in the next macro cycle. In the next macro cycle, second macro cycle, again if required, third macro cycle, still required, fourth macro cycle. That is why when you are working on the foundation field bus segment, whenever you're using a hot communicator, sometimes or many times, it will take time to fetch your data. Also, its speed is 31.25 kbps. That is also one issue, low speed. Again, the second one is it happens only in acyclic communication. That means whatever you are doing with your hot communicator, it is having the lowest priority on the communication bus. That is why whenever you're dealing with your hot communicator, it is always slow. See, it is not a problem because it is designed in such a way that it has to perform like that. So this 150 milliseconds is the acyclic communication, right? And acyclic communication is a on-demand messages, or it is a on-demand communication used for configuration and diagnostic purpose, or maintenance, logs, alarms, these things. These are having lowest priority. Remember, for easy explanation point of view, I only considered some major parameters here in this macro cycle. There are so many things. You need to go through the foundation field bus manuals to understand in depth of these macro cycle timings and macro cycle commands and responses. This is the simplest and easiest way to understand. If you have any queries, please share with us and do like our videos, share our courses with your colleagues and friends. Thank you for your support.